In this example, let's consider a spring sitting on the ground. There's my spring. And we're going to put a 5 kilogram object on it and ask the question, how far does the spring compress? Well, the way to do this is with Hooke's law, which says F equals negative K delta X. So we need to figure out the force and the spring constant. So I will tell you the spring constant in this case, it's 100 newtons per meter. And the force we can get, because if we consider our block over here and draw a free body diagram, it has a force of gravity acting on it, and it has a normal force acting on it, because it's sitting on something. And since this is in equilibrium, once it's compressed, so once it's been compressed delta x, it just sits there, it doesn't accelerate up or down. We know that the normal force is equal to the force of gravity. Well, where exactly is that normal force coming from? It's the spring that's holding it up. So in this case, it's really spring force. I'm imagining the spring attached to a platform and the block sitting on the platform, but we can just go ahead and say the spring is attached directly to the object, and it's that spring force holding it up. So now we have that our spring force is equal to our gravitational force. This is the spring force equation. So I can just substitute in mg right here and say mg equals negative k delta x. And in this case, the gravitational force and the spring force are in opposite directions, so really I should go ahead and indicate that. So now we have mg equals k delta x, and we are looking for delta x, so if we solve for that, delta x equals mg over k equals 5 kilogram block would be about 50 newtons over 100 newtons per meter, so delta x is about 0.5 meters. We could then ask an energy question and say how much energy is stored in the spring when it's compressed. Oops. So I typically write potential energy K for spring constant, but I think your book uses UK for this, or maybe even US. I'm going to use UK for potential energy spring constant here. And the formula for that is 1/2 K delta X squared. So if we do that, it's 1/2 same K, 100 newtons per meter, and 0.5 meters squared. And just doing some quick mental math, so this would be 0.25 times 100, so we're going to get 25. Half of 25 is about 12.5. And I did some rounding here, so 12.5 joules stored in the spring.